Welcome to qnawire.
In problem 7, we have some data that shows the yearly budgets for leading business sectors in the United States. And we're going to find out if there's a significant difference in the mid-budgets of the business sectors at the 0.05 level of significance. All this data is in thousands of dollars. First things first, we need to find out what this K value stands for. K stands for the number of business sectors in this case, or the number of factor levels. So K is 4 because there are 4 different sectors. Ni will be the number of samples within each business sector. So N for the beverages, we have 1, 2, 3, 4, 5, 6, 7. So Ni would be 7. Let me just separate this. And for electronics, it's also 7. Everything here, all the sectors have 7 samples or sample sizes of 7. Next, we'll have to get X bar for each of these sectors. That is the mean for each of the sectors. You could work that out using a calculator, and you will get for beverages, it is 52.29. For electronics, it is 19.57. For food producers, it is 35.29. And for supportive services, it is 25.43. Next are the variances for each of these business sectors. And you can also do that using a calculator. And you will get for the beverages, the variance is 4,521.57. For electronics, it's 157.29. For food supplies, it is 283.9. And for supportive services, it is 239.95. Also, it will be important to get the grand mean for this data. That is x bar, the entire data. So, and when you work that out by adding up all these values and divide by the sample size, which is 28, you get that the grand mean is 33.14. Now, to determine if there's a significant difference, we're going to follow these 3 steps. And first, we're going to, in part A, we're going to give the null hypothesis and the alternative hypothesis. Then we're going to get the critical value of f, and then we're going to compute the test value of f, and finally make the decision whether to reject or fail to reject the null hypothesis. So in this case, the null hypothesis is mu1 equals mu2 equals mu3 equals mu4. So we have 4 means since there are 4 business sectors. The alternative hypothesis is that at least one mean is different from the others. Okay, so the first step is done. Next, we're going to give the level of significance, alpha, and for this study, the level of significance is 0.05. The degrees of freedom for the numerator are given by the number of sectors minus 1, or simply k minus 1, and k minus 1 equals 4 minus 1, which is 3. For the denominator, the degrees of freedom are given by n minus k, and n is the total number, the total sample size, which is 28. So 28 minus 4 is 24. So the critical value of f at 3 numerator degrees of freedom and 24 denominator degrees of freedom at the 0.05 level of significance is 3.01 from the table. And now we're going to the next step, where we need to work out the variance between the groups. And this is the formula that we'll use for the variance between the groups. It's the summation of n into brackets x bar minus x bar for the grand mean divided by k minus 1. So let's fix the values, and we're going to start with ni. Ni is n. We're going to start from the first sector. So for beverages, we're going to have 7 as the sample size, and then we multiply that by the mean for beverages, which is 52.29. Then we subtract the grand mean, which is 33.14. Next, we add that to the next sector, which also has a sample size of 7. And since this is a sum of squares, we have to remember to put a square here. So this will be squared as well. So we have 7 in brackets. For electronics, the mean is 19.57. Subtract the grand mean, which is 33.14, then we square. Next, we add for the food supplies or food producers, which is 7 in brackets. The mean is 35.29 minus 33.14, which should also be squared. And lastly, we add for the supportive services 7 into brackets 25.43 minus 33.14 squared. And when you work that out using your calculator, you will find that the value is 4,303.14. Next, we go to the variances for within the groups, and we need to substitute this the values into this formula, and then we add them up. So we sum ni minus 1 multiplied by the variance, the first variance, or the first for the first business sector. So in this case, the first item is n minus 1, which is 7 minus 1, which gives us 6 in brackets. The first variance, which is 4,521.57 plus 6 all again, because n minus 1 is 6 for the second sector, and the variance is 157.29 plus 6 again multiplied by 283.9, that's for food producers, and lastly for supportive services it's 6 multiplied by 239.95, and the denominator will be the sum of n minus 1 in all the categories. So that means we're going to be adding 6 to itself 4 times. And when you work that out, you obtain the value of the variance within the groups as 31,216.29. Next, we go to the MSB, which will be obtained from the variance between the groups divided by the degrees of freedom in the numerator. And for this case, we're going to have 4,303.14 divided by the numerator degrees of freedom 3, and that gives the value for MSB as 1,434.38. Next, we go to MSW, which is the mean square or the variance within the groups. And in this case, we'll have to use the formula S squared W divided by the degrees of freedom for the denominator, and this will be 31,216.29 divided by 24, which gives us the value 1,300.68. And now we're on the last step where we need to get the value of f, the calculated value of f, and this comes from the MSB divided by MSW, and this will be 1,434.38 divided by 1,300.68, and that gives us the f value of 1.10. And now, to make the decision of whether to reject or fail to reject the null hypothesis, we shall compare the calculated f with the critical f. So in this case, we see that the calculated value of f calculated is less than f critical. Since the calculated value is 1.10 and the critical value of f is 3.10, so in the f distribution, you'll find that the critical value is 3.10, and hence the area to the right is supposed to be the critical region. And in our case, we have the calculated f coming to the left of the critical value of f, and this means that the f calculated is not within the critical region, and hence we can make the decision to fail to reject the null hypothesis. So failure to reject the null hypothesis implies that there is not enough evidence to support the claim that at least one mean is different from the others. So we conclude that there is no significant difference between the means or the mean budgets of the business sectors at the 0.05 level of significance.